Okay.
All right, we're at the Palomino plant again for the Revolve, and I want to go over the Intellitronix load shedding today. So if we come in here right inside the unit, you can see we have an Intellitronix box here, and if the 12 volt power is on, this will come on, but we will not have any 110 volt power unless we come over here and we turn on. Make sure the red energy box is on. That's the inverter controller. Yours might be on the outside also, or you plug it in. But today we're not plugged in. We're just dry camping. So we come over here and we can see that we're pulling 0% of power. So there's no 110 power going on right now. And if you scroll through here, this gives you amps. These are your actual circuit breakers on your 110 breaker box. So we're zeros all the way across. If you want to see it in watts, this is the same thing. This displays, and that's current, and this is priority. So what you could do is this is set up to make your air conditioner shut off when your microwave or something else is on, so that you can actually run all these appliances that equal more than 30 amps, even though you only have a 30 amp breaker box. So it's a brilliant. You don't have to switch. The old units used to have a switch like this where you'd have to switch between water heater and cooktop and stuff like that. Well, we won't have to do that in the future. Everything will have these kind of boxes that manage it for you. Now, also, you can see here max gen amps. Now that's 30 amps. That Intellitronix box is only going to limit to 30, but our inverter is actually only capable of doing 25. So if I go there and hit enter, I can dial that down to 25. Now, if I'm on shore power and my batteries are full, I can leave it at 30, but the batteries to charge actually take 8 amps. So if I'm plugged into shore and trying to charge my batteries and running stuff, I set it at 22 amps. So for this instance, we'll just leave it 22, even though we're using the inverter, because that's a good place to set it that works in all conditions. I can just leave it at 22 amps and it works in everything. So now we come over here and I'm going to show you that we actually put a little load on the battery a little bit ago, so it's still trying to top off the battery. So it's tapering it down. We're probably producing 300 watts of solar today minimum in Michigan in early spring because we have good sun. But it's only going to put in what the batteries need, so that's why this is just showing you what they need. And we're running the refrigerator still. It takes up to 300 watts, so we're running everything else fine. Now, what I'm gonna do here, you can see up here is I could go to low heat, low fed. There's high fed, low cool. I'm gonna just leave it. There's my air conditioner. So now we're running the air conditioner, and I got it as cold a setting as possible. It's about, let's see, we're getting about 70 degrees right now outside, and I got it in the coldest setting. Feels nice and cool. You can see where the compressor's working pretty easy at 1.1 because we're on low cool. So now I can run this air conditioner. As you can see right now, it says 4 hours and 40 minutes. It's gonna keep adjusting down because it's still trying to figure out exactly where the status of the batteries are. So you'll get that for a little bit. But usually what you should get is for every 100 amp hours, you'll get about 50 minutes of air conditioner runtime. So what we'd actually see is 345, but we're also producing sun and putting some back in. So we're actually pulling out of them more than this amount. It's probably about 1.3 kilowatts, but with the sun, we're putting some back in. So that's why it's down there lower. So it's gonna settle in about 4 hours of runtime with that air conditioner. Now, if we come over to the Intellitronix board, we can see, if we don't know how much actually the air conditioner load's putting on it, we could go back in here and we'll just scroll through. We're 40% of our 40% load, 46% of our 22 amps we set it for. So we're pulling probably about 10 amps, I guess, which would be about 110, 1100, 1200 watts. We'll go check it out here. Now you can see we got 10.4 amps actually. So I'll show you that, and we're pulling 1155 watts. So I can leave it on there, and that way if I want to see where I'm using my power, I can see it throughout the day. And that what that does is it helps me manage and be a better dry camper, because if I want to cut down and reduce, I can start shutting those loads off. And remember, this is 1, 2, 3, 4, 5. So that tells me if I come over to my breaker box, 1, 2, 3, 4, 5. So that's right there. That's putting that load on. So I know where it's at, and I can see which one actually is pulling the load. So and it's also marked here, so I can shut those off. Like the water heater, I usually shut off unless I'm just about ready to take a shower. I'll turn it on 10 minutes beforehand. That way I make sure I'm not using up all the power. So I like to use these to keep track and know how much time I have left. So if I'm only get 3 hours and 40 minutes out of there now left, then I'm probably gonna save that till that evening. So I'll use it just to cool up the unit off before I go to bed. And that'll help preserve my energy. So we'll shut that off for now. Set that off and we're good there. Now you can see that go back in. That load's been taken off of there. And now here's another thing I didn't mention. See how this is minus and positive? When it's positive and pulsing like that, this time is how long it has left until it recharges the batteries completely. So that number will start to come down as your power goes up too. So we can take all these loads off, start removing it, and you can see the watts that start climbing up slowly as it adjusts and gets that going. So now we're producing 42. It's going to keep working its way up, and the time will start getting shorter and shorter until the batteries are full. Thank you.